Alright, so displaying quantitative data. When displaying quantitative data, we will always follow 3 rules of data analysis. And that is make a picture, and make a picture. Always want to make a picture. So we have really 4 ways of displaying quantitative data. Now, by the way, quantitative data is data, it has units. So it's data with units. So height, because height can be measured in inches or centimeters. Weight measured in pounds. Okay, those are quantitative type things. IQ scores. Okay, anything where you're not counting, anything that's really measured. Okay, whenever you're measuring something, then we're talking about quantitative data. So we have dot plots, stem and leaf plots, histograms, and then we have the last one's a box plot. Box plots we'll do next chapter, but these are the 3 we're going to do this chapter. Okay, so when we're dealing with data, one thing we could do is we can put it in our calculator. So we go to stat edit, and whatever's in L1, just go up there and push clear, enter. L2, clear, enter. So we have a pretty small data set here. So in L1 I'm going to put in 5.5, 7, 9, 10.5, 13, 11, 10, 9.5, 10.5, and 12. Okay? And then what I'm going to do is, to make life easier, I'm going to go to the stat and then sort A. Alright, so stat sort A, and I'm going to say OK, second 1 for L1. And all that's going to do is sort the data for me. So now when I go back into stat edit, it now put all of the data in order for me. So I see 5.5 is my lowest, and if I just go up, I see that 13 is my highest. So I have to go from 5.5 to 13. Okay. So we're doing shoe size data here. So I need to make a plot that goes from 5 I'm putting the whole numbers in, and then the half sizes I'm just putting a dash. Okay, so as I go and I scroll down on my calculator, I can see that, let's see if I can do this right. Yeah, there, you can see that better now. Okay, so 5.5, I put a dot, 7, I put another dot, 9, I put a dot, 9.5, I put a dot, 10, I put a dot, 2 10.5s, and 11, 12, and the 13. And we'll just title this shoe size. Okay, so there's our shoe size data. Now the next thing I do is what's called a stem plot. So my stems, a stem and leaf is used when there's a moderate amount of data. Draw a stem plot for the shoe size data. The stems can be multi-digits, but the leaves can have only 1 digit. Round or truncate values if necessary. Well, we don't really need to round here. I just have to go from size 5 to size 13. So my data set again, if I go on my calculator, I'll go over here. Let's see. 5.5, so I'm going to put 5.5. 7 is 70. 9 is 90. 9.5 is 9.5. 10 is 10.0. 2 10.5s. an 11, so I'll put a 0. A 12, I'll put a 0, and a 13, I'll put a 0. Now I have to put a title, so I'm going to call this shoe size. And I had to put a key. 5/5 equals size 5.5. It should be an S, not a 5. Okay? And lastly is a histogram. Histograms are used for large amounts of data. So, here's what we do with a histogram. We put the counts going up the side. So 1, 2, 3, 4, 5, and then we put the scale going down the side. So we could kind of, a little dash there, and this would be 5, 6, 7, 8, 9, 10, 11, 12, 13. This is a shoe size graph. So 5.5 is between 5 and 6. Let me get that up. So I'm going to just say, okay, there's 1 from 5 to 6. And then size 7, now whenever it lands right on the mark that's between bars, we always move it to the right. So size 7, we have one size 7 to 8. And then size 8's none, but size 9 we have 2. We have a 9 and a 9.5. So I'm going to go up to 2. And the next one we have a 10 and 2 10.5. So that goes as high as 3. Now notice this is not like a bar chart. A histogram, because these are continuous, what we call continuous intervals. So for instance, if I'm looking at height, somebody can be 50 centimeters tall, they could be 50.1, they could be 50.2. So there's no break in the data here, not like a bar chart, okay? And then we got to go to size 11, there's 1. And then size 12, there's 1. And then size 13, we got to make another one. From size 13 to 14, there's 1. So that's what a histogram looks like. So advantages and disadvantages. The advantages of using dot plots, what's nice about these is they keep the individual data values. This allows us to more easily identify the center. The disadvantage is that neither handles large data sets very well. The advantage of using a histogram is that it handles large data sets very well because it puts everything in the bins. The disadvantage is the individual data values are lost. So we lose those, which could make finding the center a bit harder. All right, describing a distribution. So when describing a distribution, we talk about these 3 key things: center, shape, and spread. Center, shape, and spread. You should also mention any unusual features like outliers. So the center is a value that attempts the impossible by summarizing a distribution with a single value, such as the mean, the median, or the mode, which you learned about all 3 in middle school. Mean is the average, the median is the middle number, and the mode is the one that occurs the most frequently. When we talk about shape, we talk about 2 things: modality and symmetry. Unimodal means there's 1 peak and 1 mode. So unimodal will kind of look like this. 1 peak. Okay. Bimodal, 2 peaks, 2 modes. So bimodal, you would have something like, if I was to graph on the same graph heights of males and females, Well, the females would look like this, and then you would get another peak over here for males. Why? Because the typical male is taller than the typical female. Okay? In uniform, all bars are approximately equal. So you'll get something that looks sort of like this. And then you would have, let's say, different categories. So if everything looks about the same, then it's uniform. Symmetry is both tails are roughly equidistant from the center. So what I drew up here is symmetric. So if you had something that looked like this, that's symmetric. Okay? Notice the word roughly. In statistic, things are not perfect. So as long as it's roughly equidistant, we're good. Skewed, one tail is noticeably farther from center than the other. Okay, now skewness goes to the tail, not to the cluster. What do you mean by that? Skewed right means that it would look like this. That's skewed right. Okay, the tail's to the right. Skewed left would look like this. Okay, so the cluster is to the right, but the tail is to the left, so this is skewed left. So let's talk about shapes of the distributions. Well, what do we have here? This is bimodal, and both modes are pretty symmetric. This one, we would say this is uniform. All the bars are roughly the same size. This is unimodal, one mode, and symmetric. This is unimodal, one mode, and skewed to the tail, skewed left. This is unimodal and skewed right. Okay. Now spread is a numerical summary of how tightly the values are clustered around the center. The statistical term for spread is variation. Which is synonymous with spread. So let's take our distribution here. So let's take a look at this distribution for shoe size, and I'm just going to use the stem plot. Okay. Now the nice thing is with a stem plot, since we have the individual data values, if I can get the center very easily, you can say, okay, well, what's the one that occurs the most frequently? Well, 10.5 is. Now, is that a typical shoe size for males? In this case, you might make an argument it is. Okay. I'm going to also find the median. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. So the median would occur between the 5th and the 6th. 1, 2, 3, 4, 5, 6. So in this case, we know that the mode is 10.5. The median is going to be 10.25. And if you were add them all up and find the average, the mean is 9.8. Now I like to use the median. So I'm going to say that remember I got to talk about center, shape, spread, and outliers. So I'm going to say the median shoe size is size 10.25. Now let's talk about the shape. Well, this is unimodal and symmetric, with most of the data values clustering between sizes 9 to 11. Okay? So the distribution is unimodal and symmetric, with most shoe sizes clustering between sizes 9 and 11. 9 to 11. Okay? Center, shape, spread. Well, how do we look at variation? Well, probably the only thing you know how to do right now is called the range. Okay, the range. So the range is simply the max minus the min. So we got size 13 minus size 5.5, so that's going to be size 7. So the range is 7.5 shoe sizes. Okay. And the last thing we talk about are any unusual features. Well, we might argue that size 5.5 could be considered an outlier. Could be. Okay. Now notice when I described the distribution, the other thing I did is I described it in context. I didn't just say the median is 10.25. It's the median shoe size. When I talked about the distribution, the shape, and the spread, I talked about shoe size. So when we summarize any kind of distribution, we always do it in context. Alright, so now how do we compare distributions? Well, the key to comparing distribution is to make sure that all data and graphical displays are on the same scale. So now we have shoe size data, and we have two different, two different genders. So we've got to make sure that both of them are on the same scale so we can compare them. So we're going to have to go from size 5 all the way up to size 14. So this is going to be females, and then males will be the same thing. So what we're going to do is that's 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. So females, we had a 5.5. A 6, 2 7s, 7.5, an 8, and a 9. For males, we had a 9, 10, 2 10s, a 10.5, an 11, 11, that's not there, a 12, and a 14. Okay? And we'll just title this shoe size. Now back-to-back stem plot, now what we do is the stems have to be the same. So we're going to do 5 all the way up to 14. And over here it's going to be females, and over here it's going to be males. So females, 5.5, 6 will be 6.0, 2 7s and a 7.5, an 8 and a 9. For males, it's 9, 2 10s, 10.5, an 11, a 12, and a 14. And then 5-5 equals size 5.5. Now histograms, with histograms we would like them to be on the same scale, but in some cases it's harder to do than others. So generally with histograms we kind of plot them individually, though we could plot them on the same scale. But so for females I'm going to do size 5 to size 9, and I'm going to have a count like that. So let's see, size 5.5, there's 1. Size 6, there's 1. Size 7 and 7.5, there's 3. Size 8 to 9, there's 1. And size 9 to 10, there's 1. Pretty symmetric. Okay. And then for males, I'm just going to call this female shoe size. And then for males, I'm just going to put them over here. And yeah, I'm going to do it. And males start at 9 and go all the way up to so let's see, males size 9, there's 1. 10, 10, 10.5, there's a 3. Size 11, there's 1. Size 12, there's 1. And size 14, there's 1. So this is male shoe sizes. Okay. So when we compare distributions, we compare center, shape, spread, and unusual features. So I like to use the back-to-back stem and leaf. So there are, let's see, 7 values for females. So this is the median right here. That's the 4th one. And there are 7 for males. So right here is the median. So to compare center, I'm going to say the median shoe size for females is size 7, while for males it is size 11. The typical male shoe size is larger than the typical female shoe size. So there we talked about center, we compared centers. Now we talked about shape. Well, for females it's unimodal and symmetric, but most shoe sizes in the size 7 category. And then for males it's slightly skewed right, with most of the shoe sizes in the size 10 category. Okay. So the distribution of shoe sizes for females is unimodal and symmetric, with most shoe sizes in the size 7 category. The distribution for males is unimodal and skewed right, with most shoe sizes in the size 10 category. Okay, and then the last thing we would talk about is range. So we go from, for males, we do 14 minus 9. So the range is 5 shoe sizes, and for females it's 9 minus 5.5. So that's 4.5. So the range for males is 5 shoe sizes. And for females, 4.5 shoe sizes. So males have more variation in shoe size. Okay. And then I look at this, and the 14 could be an outlier, but it's not so far out. So I don't really see any outliers, so I wouldn't note anything as being an outlier.